Okay, Bismillah. Okay, folks, welcome back to our GCC class. We're looking today at compound interest and depreciation. The questions on the left-hand side, the Maths Watch Clip 137 Grade B questions. So I'll be modifying the numbers a bit to generate new questions. So please bear with me on that. So there's our title. I'll just put, if you want me to, I'll just do another one over here. Okay. Oh, that's nice. Okay. All right, lovely. So compound interest and depreciation. Right. All right, let's have a look. I think that one's a bit. Let me go for that. Okay. It says Henry places £6,000 in an account which pays 4.6% compound interest each year. Calculate the amount in his account after 2 years. So I'm going to change the numbers to. So now we say that Henry sounds like a vacuum cleaner. So this Henry, he actually has £7,000. Okay, and that looks still a bit. Okay, and he the account pays 3.5% compound interest. Okay, and we want to work out how much will he have in his account. So he leaves it in his account for 7 years. So we're using the same question style, just changing the numbers for our example. Okay. Okay, now, so when we do a compound interest question, this is how we start off. So first of all, we start off with our principal amount. So we get our principal amount, which is £7,000, and then we multiply it by the percentage now. Remember, 3.5% is going up, isn't it? Yeah, so we got 3.5%, which is increasing. Now, what is the original percentage? Original percentage is worth how much? 100%. So 3.5% is how much it's going to go up by, and if we counter in how much we're going to, our original percentage, so altogether we are going to be working out per year, what are we going to be working out? 103.5%. So this is how we interpret the question. So even though we mentioned 3.5 in the question, we're actually using 103.5. Okay, push that. Okay. Okay, right, okay, sorry about that, some little technical. Okay, so 3.5% compound interest means we interpret that as 103.5. Okay, right, let's, I don't know what happened there. Okay, let's go back. Right, so when we do our multiplier, we do our multiplier as though we are thinking about 103.5%. So I haven't finished with that yet. Let's leave that there for the moment. So we interpret this as that because we've done our little modification at the bottom by adding 100 onto it. Now, it's going to be done. That's going to be done again and again. How many times? 7 years. So after we've done this, then the next year we're going to do it again. So we can do this value times by 103.5 again, then times by 103.5 again. So the quickest way of doing that is to put a power here of 7. So I'm gonna now at the moment I'm not happy with this. At the moment we change into a decimal multiplier. If we change 103.5% into a decimal multiplier technique, we have to divide it by 100. That gives you 1.035. So really this number here should be. So let's quickly change that. Okay, so 1.035 to the power of 7 because we're going to multiply it by this particular number 7 times again and again and again. So 7,000 was our principal amount. If I can choose the black. I'm trying to choose the black, being red still. So £7,000 multiply. So this is our actual calculation. This is us working up, getting up to our calculation. So this is the actual calculation. So the principal amount multiply by 1. Actually, it's 1 plus the. Okay, now I'm not going to do that. There's actually a way of writing it down. 1 plus the rate over 100 to the power of t. That's the actual formula that I've actually used to work that out. So that formula, if you want to put a red box around your formula here, please by all means do so. Right. Okay, that one is too low. Okay, gotta delete that. Okay, right. Has everybody got that formula first of all? So the principal amount times by 1 plus the rate of interest that the charging divided by 100 to the power of t. That's basically what we've done here. Okay. Now we need to work out this value here, 7,000 times by 1.035 to the power of 7. So we need a calculator. Right, does everybody who needs a calculator got a calculator with them in the class? So we got one. Okay, ladies at the back, we all sorted. Mr. Han, you can borrow one of mine. Okay, everybody else got one? One here, lovely. Okay, let's get the calculator out. Okay, let's put the calculator over here. So we're going to do this calculation here. This one. So everybody please quickly do it on the calculator as well. We need 7,000 times by 1.035 to the power of 7. So we get an answer of 8905. I'm going to squeeze the answer in over here. 8. Okay, let's try that again. Okay, no. That's better. 8 9 0 5. Okay, you got the same?
Yeah.
Yeah, on your calculator? Yeah. Now we're going to give it to 2 decimal places because we're looking at decimal money. So 0.954 becomes 0.95. So it started off with £7,000, and the compound interest, so interest is applied upon interest every year. Okay, and then at the end of it all, he had 8,905 and 95 pence. Now the formula which I've just kind of like introduced at the last moment, I will just show you how we use that in the next question. Okay, because I've done it in manual way, then I'll show you the formula. So apologies for that, for introducing the formula at the end. So we will actually use it in the next question. Have you all got that one first of all? Yeah. Okay, I'm going to clear the screen on the right hand side, the one that says compound interest. Has everybody copied it down? So I'm going to clear the screen. I need that space. Get it done? Mr. Han, you copied it all down? Okay, right. Here it goes. I'm just going to get a new page now for myself here. New. Okay, lovely. Let's get this down. Okay, let's have a look at another question. Okay. So now that's a question where everything is going up. Now we need to look at questions the same mathematical technique, but everything going down. Depreciation. For example, the best example for depreciation here, so don't forget we've got depreciation as well. Depreciation is like compound interest, but in reverse. Okay, can you see the clip number? Have you got a new sheet in front of you? Just share with the person next to you at the moment. We'll sort one out if there's one short. I think actually there is one short. So depreciation, so let's have a look at this. So we got here, loader buys a new car for question number 6 for 14,600. The annual rate of depreciation is 23%. How much is the car worth? Oops, I shouldn't have pressed that. How much is the car worth after 3 years? So we're going to use that style of question. So let's have, for example, okay, we have, okay. So we have a Mercedes here. Okay, Mercedes. This is a Mercedes. Okay, it's an E320 CDI. Okay, this car when it was new, it cost £29,600. Fully loaded avant-garde model. Okay, don't ask me how I know all this information. Okay. Now, we want, and this car, because it's a Mercedes, it doesn't lose 24%. That's just disgusting, 24%. It's a Mercedes, yeah, so it doesn't lose 24%. Say we say it loses 7%. Okay, well, we'll be more, okay, 11%. So it has 11% depreciation. Okay, don't forget it's a good car, it's a quality car. If you ever need servicing, you go to MSL on Stafford Road and they will service this car for you at no extra charges. Especially if you know the manager. Okay, so right, we need to work out the value of this car in, okay, what was the value of the car after 3 years? Okay. Now, let's have a look at this 11% depreciation. So it's going down by 11%. So what was the original value of the car? The original value of the car was, how much was the value of the car? 100%. And we are losing how much per year? 11%. So 100% minus 11% gives us 89%. Now 89%, if we quickly now in one, since we're on the go, 89%, if we change that into decimal multiplier, is written as what? 0 point? Lovely, 0.89. How do we get that? Let's quickly remind everybody in the room. We divided it by 100. So, because 89% means 89 per 100. So 0.89 is our decimal multiplier, which we'll use in the question. Maybe you're happy with that, yeah? So they mentioned 11%, but we're not using 11 in our calculation. We're going to be using 0.89. That's how we interpret the 11. You happy with that, Junaid? Good. Now, let's start off with the value of the car. So what was the value of the car originally? So the original value of the car was 29,600. Remember, this is the avant-garde model. It's the good one. Yeah, it's the one that's worth buying. Okay, and then we're going to multiply it by the decimal multiplier, which is this number over here. So it's 0.89. So that includes 11% depreciation. Now that we're working out for 1 year, but we have to do for 3 years. So where does the 3 go? It goes there. Because what we're doing in a sense, if we're doing 29,000, we're going to knock off 11% and then do it again and then do it again 3 times. So it's like the same as multiplying it by the multiplier 3 times. Okay, are we happy with that? So that's the calculation we need to do. And then we grab our calculator, our trusted Casio FX9860G. So we do 29,600 times by 0.89. And that's to the power of 3. And that gives us a value of, fantastic, well look at that, 20,000, still worth 20 grand after 3 years. Told you it's worth every penny. Okay, right, so that gives us £20,000, 867 and 8 pence. Okay, but you don't have to be silly to buy brand new anyway, just buy second hand. Okay. Are we happy with that question? Are we happy with how depreciation works now? Yeah? Okay, that's going to be the end of our demonstration and our examples for this particular clip, compound interest and depreciation. I'm now going to give you some questions to do. So we're going to pause the video or stop the video here. I'm going to give the class some questions to do. Okay, are we happy with that, folks?